Assalamu alaikum everyone. So today we are going to discuss introduction to machine learning. Some of you are already aware with machine learning, maybe all of you, because nowadays it's like a very important area, and you can apply machine learning in different aspects. So the agenda for today is to discuss machine learning, what is machine learning, and then what are the applications of machine learning we can have. So we will get some idea about it. This is the thing which we are going to cover in today's session. So two contents we are going to discuss. We will discuss what is AI, ML and DL. So AI is the broader concept, the main umbrella in which you have ML and DL. And then we will discuss some of the applications. As all of you knows that it is, okay, screen is not moving. Resume slideshow. So AI is attempt to endow a computer with some of the intelligence, like in our human, we have neurons, we have synapses. So we are trying to mimic this idea, like how brain works, so that we can train our machines. And then these play a very crucial role in different aspects, in different type of areas. There is a timeline, it's not new. I think all of you have done this course, compiler design. In compiler, you have heard about Turing machine. So it was developed in 1935. So machine learning, it is very useful nowadays. It is gaining momentum. And you see the timeline, AI is not new. From 1950s, AI is there. When computer was invented, in which year? Any rough idea, rough guess? Yes? Yes. So this is one of the very basic start in 1935. This abstract computing machine was there, and the idea was to get a limitless memory scanner, and then machine learning comes into the picture along with computers. 1970s we can say. It starts. And then the data grows also. Earlier, the computer size, if we say hard disk, was like 500 GB, earlier 100 GB, 10 GB. Nowadays, 1 TB, 2 TB, 5 TB are nominal sizes. Earlier, when you click pictures, the size were in KBs. Nowadays, the size is huge. The more megapixel you have maybe in your camera, more power, it collects more data. So data science then comes into the picture with big data along with deep learning. So we will discuss these, like how they are coming. So AI is a broader context. AI is the umbrella in which we have machine learning and deep learning. So machine learning is application or subset of AI which allows machines to learn from data without explicitly being programmed. So basically it learns from the data. What do you mean by it learn from the data? You feed some of the data, and then there are algorithms, there are models. We will discuss in which type of context, which type of machine learning we will apply, so that it will be clear to all of you. After this, deep learning is a subset of machine learning, where you have multiple like deep neural networks. You have RNNs, you have CNNs, we have now power of GPU, we have more advanced models, more advanced activation functions, and so on. So development of AI, it's not new. If you see, it's 1956, Dartmouth workshop, 1950s AI programs which were chess playing. Recently also, if you download some of the chess games, they are using AI. By the time you play with them, they are increasing their capability. In starting, maybe you beat them easily, but after playing some number of games, it becomes difficult. Why? Because of learning. Then in 1957, Frank Rosenblatt have development of perceptron, which is later known as MLP. And nowadays we known as like DL. It was previously only neural networks, shallow networks. Nowadays we have more number of layers, so we say deep learning. And then machine learning techniques getting famous. In 2010, deep learning like CNNs, RNNs were there. And current time AI, all of you knows that current time is basically for transformers. Not the movie Transformer. Transformer here, these are advanced models which are highly useful in NLP, natural language programming or processing. And then generative AI. Generative AI example is like ChatGPT. So basically, these are pre-trained transformers. So ML involve training the models, and based on those models, it makes some prediction on new data. And it includes supervised learning, unsupervised learning, and reinforcement learning. So when we see machine learning, it's a field of computer science, but it is applicable to almost every field where you have data. You can apply cross-disciplinary, because the days are gone when you are isolated in one particular domain. Nowadays, if you are versatile in data science, in machine learning, in deep learning, the requirement for different areas are there. Because let us say one example from chemical engineering. So chemical engineering person give you data related to chemicals. It will tell you what are the reactions if you make these two substances together, what will become. And based on that, as a machine learning engineer, you can use that data. You can use all this stuff and then come up with better solution. Another example I would like to take, I generally give to this example in my class. So all the students who are already with me, maybe they just think whether like other student can answer. We are saying we are using AI. AI still is confused between cat and dog. When you do classification of cat and dog, it's not 100% correct. But if I can tell any one of you and I'll show you a picture, you will most probably by 100% accuracy you will say it's a cat or a dog. So why we are using AI? Humans are far superior when it comes to do classification of these type of things, which we are very like having more experience. If I'll show you a picture of cat and dog, you will easily say it's cat or dog. So why we are using AI? It is still not 100%. More faster. But human are also very faster. Okay, accuracy, as I mentioned, humans are still more accurate when you do classification of cat versus dog. Any other? Some time, after some time, maybe, probably. Okay, good futuristic answer. Anybody else? Huh? More smart than us. Okay, yes. Can handle complex problems and environments. Yes. Huh? Size of the data. This is the most correct answer. If I'll give you 5 pictures, 10 pictures, it's good. Suppose the moment I say, okay, what is your name? Fare. So if I say to Fare, 5 images, you need to identify cat and dog. He will be happily say, this is cat, this is dog, here it is cat and dog. The moment I say, okay, no problem, you have good time, 10 days vacation is coming, just take these 5 million pictures. What happened? It will be difficult. So what we are doing? We are doing automation. Like you go for airport, there are hundreds of thousands of CCTV camera. Fare can see all of the camera together, difficult. If you employ 10 persons, 20 persons, again it is difficult. So rather than doing these things manually, which is quite subjective, because I know my student, when they take a very good meal and then we have a lecture after, their afternoon and they feel sleepy. But the good thing with AI, it doesn't feel sleepy, right? So that's why automation is required. So let us see here, this is the label data. We give the label data to the machine, and then we try to train this model, machine learning model, any model. So training or learning, you can imagine it as a child. You will show some of the chairs to a child, to a kid, maybe 3 years, 4 years, that this is a chair, this is a chair. You will show him or her 4 or 5 type of chair. The moment you bring 6th chair, which the kid never seen, kid probably say this is a chair. Why? Because this is learning. So similarly, we are training the models. So here, suppose I am taking example of labeled data, means supervised learning we are discussing. So after our ML model is trained, we will show some of the unseen data, which is not already seen by the model. And it will predict. I hope, inshallah, today you will also predict some of the model we will discuss, supervised and unsupervised. We will see the case. Let us say how much time we have, and then we will apply, all of us. So supervised, it is labeled data. What do we mean by label? We know the class. There is some labeling information. Data is having some sort of supervised way. Like right now, if I am teaching you something, so this is supervised. Unsupervised, you explore on your own. Third is reinforcement. I will say, if you solve this question, you will get 10 marks. That is reinforcement. So we will discuss all this stuff. Unsupervised, we don't have labeled information. So then we can apply clustering. We can apply unsupervised learning. And I already mentioned about reinforcement learning. Like you say, you do this certification from this particular company, you will get these marks. And students are doing for that, and they are getting. This is reinforcement learning. So classification, what is classification? In case of classification, it is the task of categorizing or classifying. It is the task of categorizing or classifying. If somebody have water, you can have some water, my dear. So classification refers to the task of categorizing data points into predefined classes. Like you see sometime these bins, which say dry, trash, or you have some sort of, organic or plastic or metal. So these are predefined. So these are labeled with organic, with paper, glass, plastic, and you can put your garbage accordingly. So this is example. This is a simple example of classification. Okay. You are getting your grades, A plus A, B plus B, C plus C. This is also one more example of classification. Right? Students are classified based on some marks. The criteria is fixed. How much marks for A plus? 95 to 100. So this is the label. This information is already with you. So you know about it. Now what is clustering? Clustering, we don't know the label. We don't have information of this 95 to 100. We don't know. 90 to 95 is A. So this information, this labeling is not with us. We only get the marks, and we don't know what are the grades. So we can cluster those students together based on the similarity. Now similarity come up with distance. I will explain this later. But this slide will make things clear. What is the difference between classification and clustering? Everybody, is it visible to all of you? So you have some of the birds and some of the mammals. And if you see here, ducks, here you have goat, here you have cock, here you have sheep, rabbit, and suppose turkey. So these are classified. Suppose now from our gate, one duck is coming. What we will do? We will place this duck here. This is classified. But suppose we have no idea about it. There are no predefined classes. Then we can do the clustering. In absence of labeling, we can do unsupervised. So in unsupervised, we have clustering. There are two clusters based on the similarity. So what is this cluster? How this cluster is formed? These are Excellent. These are birds. And these are animal, you can say. Okay, good. So these are two clusters. So this is classification, this is clustering. Is it making some difference, some sense? Okay, good. But now you will solve, so you will get some more better idea. No issue. How to decide which machine learning model you will apply? This is important thing. So if the question is good or bad, cat or dog, A plus or A or B plus or B, then we are talking about classification. This is the problem related to classification. When we say, is this weird? So like, suppose in this room we expect 50 students. Suppose 500 students come. Teacher is prepared for 50 students. For example, chairs are 50. So if 500 students suddenly came, it means it's not normal, it is abnormal. Let us take another example and you will give, what is the example I am talking about? You will give me the word. Suppose Majma University website on a daily basis have traffic of around 10,000 requests or 10,000 persons daily visit the website. Suddenly one day, there is a traffic of 1 million nodes on Majma University website. So is it normal or abnormal? This is abnormal, right? So what is the type of attack it may be possible? Very good. It may be DOS or DDoS. Flood basically. So flood means fake request which basically take over all the resources of that particular website or portal. Good. How much or how many? Means we are saying if two things or three things are dependent on each other and we are trying to say how much. How much will be the temperature tomorrow? This is the problem related to regression, right? Then how the things are organized. Suppose somebody give us marks of the students and say there is no grading policy. We don't have policy, just make two clusters. Marks are from 0 to 100. And the assignment is we have no policy, just make two clusters. So what these two clusters should be have? 0 to 50 cluster number 1, above 50 cluster number 2. So we can make two clusters. That is unsupervised. In unsupervised, we also have dimensionality reduction like PCA. So we will discuss later what is PCA. What should I do next? This is reinforcement learning. If you are doing good in your assignment, you will get better marks. If you are, present in your class, then you are getting class attendance marks. So this is what reinforcement. So you are doing something based on some criteria. Some more problem, and I hope you will answer. If we predict whether an email is spam or not spam, this is which type of problem? Excellent, classification. If we want to recognize handwritten digits from 0 to 9, which type of problem? Organization. Yes, correct. It is classification. Good. This is again classification. Third, identifying whether an image contains a cat or dog. Again classification. Good. Fourth is recommending movies or products, maybe Netflix or YouTube or Amazon, Noon. So what is this type of problem? Recommendation. It is basically, recommendation is another type of problem. Recommendation systems. So Netflix, YouTube, they are using that. And if we have very, very large data, so then to understand, to handle that particular data, we can use big data analytics, where we have Hadoop, Hive, all these things comes into the picture. Predicting the price of house or land based on what is the area, maybe square meter, number of bedrooms. Very good. This is regression problem. Excellent. Automatically translating text from English to Arabic or Arabic to English. This is NLP, natural language processing. Segmenting customers, maybe STC or Allergy Bank, they are segmenting their customers based on their behavior and characteristics. Or if you go for a mall, maybe Panda, Nesto or Lulu, they are putting some items together. If there is a chips, then cold drink should be nearby. If you are going to buy shoes, socks will be nearby. What is this phenomena? Excellent. This is clustering. Very good. So what are the use? There are so many use. It is outside the scope of any number of slide. Huge self-driving cars, web search, social listening applications, marketing price model, text-based sentiment analysis, and fraud detection, pattern recognition, credit score, prediction of success or failure, online recommendation, and generative AI also. Now we see the deep learning. It is the specialized branch of AI with better computing power, better models, basically. So DL algorithm learn and represent data in multiple layers. So when we say multiple layer, we are talking about hidden layers, basically. Earlier, we do not use this term deep learning. In earlier time, I am talking about 2000, we used to say neural networks. Now it's rebranded as deep learning with more number of layers, better computation, GPUs, and better models we have. So it's very useful in different type of applications like image recognition, in natural language processing, and speech recognition. If you want to see the difference, what is the difference between machine learning and deep learning? In machine learning, you extract the features. You need to extract the features from your data. But when we talk about deep learning, this function of feature extraction is now automated. Feature extraction plus classification. Let us take example. You need to train your machine learning model. What is a cat? So what you will say? How you will train your model? What you will say about cat? All of you know cat? Bisa? 4 legs. Very good. But dog also have 4 legs. Small. Some dogs are also small. Huh? Oh, mustache. I think dog also have mustache, no? Tiger have mustache. Okay, good. So very one good feature given by, what is your name? Abdul Rahman. Very good feature he tell us, mustache. Any other thing? Color. Color. Dogs also have nowadays beautiful colors. Small nose. Yes. Shape. Okay, good. Very good. Anybody else? Huh? Tail. Okay, good. Sound. Very good. Cat and dog have different sound. Good. So these are the features. If you need to train this and training machine, you need to give it, if you are using machine learning, you need to extract the feature. And you can convert it data into some numbers, and then your model can understand. Even you are using, suppose NLP, so no need to convert your data. It will be converted by different ways. Form of NLP, you can use BERT, glove, word-to-vec, other things. Here in this case, this feature extraction thing is automated. You need to give the bounding boxes, just bounding boxes. You can use automation like RoboFlow. You may have 100 of images. You can put it with your data. And you try to train the model on your data set, customized data set. Because whatever pre-trained model you are using, that is trained on a very good data set, maybe MNIST or any other, COCO or any other data set. But you want to customize it for your need. So you can give your own data set also. So why is useful? Easy to adapt, fast to learn, very flexible, universal, and it can do both way, unsupervised and supervised. It is effective end-to-end joint system, and it can utilize large amount of training data. Now, if you want, all of you, we can just see like how these things are doing, like classification and clustering. How many of you are aware with Euclidean distance formula? What is Euclidean distance? Based on this, I will explain supervised learning and unsupervised learning both. You can use any other type of distances also. So let us see this example. This is k-means. K-means means clustering, unsupervised. This is the formula. These are the points x, a, y, a. This is another point x, b, y, b. So what is the distance? What is this distance? This is xb minus xa square plus yb minus ya square. Very simple formula. We can have different distance formula as well. But let us see how k-means work. There are some data. Suppose this is big data. However, this is not a big data. This is very small data. Right now we are taking example because as the time is less, so we understand with this data. These are some of the data points which contains height of the persons and their weights. So we want to, the problem is do unsupervised learning and make k equal to 2. Means we need to make two clusters, k1 and k2. So we have these clusters, k1 and k2. So we need to do the initialization. So what we will say, first point will go to k1. Second point we will send to k2. This is initialization. For the initialization purpose, we are doing that. Now, for the third point, this is our third point, 160 and 60. We want to put this point, this is third point, into which cluster, K1 or K2? So here the formula is talking about similarity. Similarity means how close you are. Let us take example. The persons of Majma, they are, suppose two persons are neighbors. So they can speak similar language, similarly. You go to 1000 kilometer and you will see there is a little difference in the language. What do you mean by this? That more close, more similar. This is the fundamental we are discussing. So we want to calculate the distance of this point between this and this. So these two are the cluster of K1 and K2 right now. So we will take 168 and 60. So we will first see in K1. Now the value of K1 is 185.72 and the value of K2 is 170.56. So we want to check. So for the third point, if we want to check with K1, what we will do? 168 minus 185 square plus 60 minus 72 square. And we get some distance, which is 20.80. So right now this distance is not kilometer or meter. This is just number, right? Now we will check this. What is the distance of this point with K2? So 168 minus 170 square, 60 minus 56 square, and it is 4.48. So tell me, point number 3 is closer to K1 or K2? K2. So what we will do? We will put our third point into K2. Let us just, after this we need to update the centroid, right? So what centroid updation is? We take the mean of the value for the new point and then we will move forward to update it. So if suppose we updated now the fourth point. So fourth point, again take 179 minus 185 square plus your 68 minus 72 square. And then it will take distance from second point also. And then we can do this calculation. So this is very easy. The formula we are using Euclidean distance. So here unsupervised learning. Let us take another same example, Euclidean distance, but this time we will use it into supervised learning. So this is KNN. KNN is what? Supervised learning. Formula is same, distance. We can use other distance also. Suppose this is a scenario. We have two subjects, CS 460, CS 462. And these are the results of the students, fail and pass and whatever. One student came, he said that in 460 I got 6 marks. In 462 I got 8 marks. I don't know my label. Please classify me. Suppose his teacher is gone, maybe for vacation. He say, okay, only one student left, I am going summer vacation, see you later. And he gone, suppose. So then this student is coming to the other class. Please give me what is my grade. Okay. So now how we do this classification? Yes. Yes, please, please. So here again the same formula, Euclidean distance. So these are 5 students. So we will see this new student, this poor student who don't know his grade is near to which student. Again same formula. So 6. So first we take the distance of this student from this. So 6 minus 4 square plus 8 minus 3 square, and we get root 29, which is 5.38. Let us take with the second, 6 minus 6 square. What is 6 minus 6 square? 0 square. What is 0 square? 0. Very good. Plus 8 minus 7 square? 1. So it will be, we put value 1. Similarly 1, 3.162. So now tell me, this new student, if we say k equal to 3 least value, which are the 3 least value here? 1, 2, 3, or 1, 2, 3. These are the 3 least value. So student 2, student 3, and student 5. Student 2 is pass. Student 3 is, student 5 is, so this student will be pass. So this is how it works. So you see same formula. What is Euclidean distance? Simple. And I hope all of you are aware. So machine learning is super easy thing. When we do this type of work, we use only sklearn, which is library developed by someone. We are not making our own. Maybe you can make your own. There is no problem. And the code for this work may be 3, 4, 5 lines. That's it. Take some NumPy, pandas, import your data maybe in CSV. So pd.read CSV. And then use these models. The major thing, how to tune the parameters, how you are tuning, how you are using, because this data is very easy. If the data size is huge, more features, then how to reduce the dimension so that it can be properly come to the scale what you want. Should we always use Euclidean distance? No. I hope because of stats you are aware that you have, apart from Euclidean distance, you have Manhattan distance, which is developed in 1841. And we are discussing what? Machine learning. We say it's new. And method we are discussing of 1841, Manhattan distance. We are using PCA. We are using LDA. PCA 1901, LDA 1936. What is this going on? And we say we are using machine learning. So machine learning is based on the basic foundation is mathematics. Is mathematics new? No, it's very old. Then you can use another distance, Minkowski, cosine similarity, and others. There are different applications of ML and DL. So I will not discuss each of them in very detail, but just give, because time is also less, some of the application, main application. So this is application 1, which is basically talk about climate change forecasting, where the model we used, it is LSTM, long short-term memory. It's good for time series analysis. And then this is the model, and we have tuned the parameters. We have taken the data from different sources. Second study is basically about air pollution. So how we can classify air pollution into different classes. The data is taken for some good number of stations. The data set is huge here in this case. AQI, PM10, CO, NO2, PM2.5, all these were taken and then analyzed. So whenever we apply ML, EDA is required. Understanding the data, what data is telling to you. Data is telling to us, we just need to look at the data, what data is trying to tell us. And then there was a problem of class imbalance. In machine learning, there are different problems. overfitting, class imbalance. So for that, we have different techniques. For class imbalance, we have SMOT, Edison. For overfitting, we have dropouts, penalties. Overfitting, we can prevent using dropouts and others. These are the hyperparameters which we tune. If you don't tune hyperparameters, your model still give you the results, but it is not stable. You bring new data and it might fail. It might not good working well. Another study is basically used in ice. What is the thickness? Because you need to send the machines on the very high altitude, and it's very difficult. So this study basically used neural networks, shallow neural networks, to get the thickness of the ice subsurface. Then come back to the Saudi Arabia related application, where here we don't have glaciers. Here we don't have large rivers. It is there, but right now the water is not that much. So this study talk about anybody from Qasim here? Qasim region, Bureda? No one. Okay, you are from there, good. So you must be recognize this. What is this? Huh? Farms. Why these are circular? Why not square? So that it can look like beautiful? Why? For the watering, excellent. Because pivot agriculture, they put on center. This is the axle, and this machine rotate, sprinkler basically we used to say. Why we are doing this? It should be agriculture work. We are discussing ML, AI, computer vision. So you must be aware that computer vision, AI, ML are integrated part of sustainability. Sustainability is one of the main priority not only for Saudi Arabia but throughout the world. It is very, very important. So here what we have used again CV, AI, ML, and to understand what is this Tom and Jerry is doing in this slide. Not by mistake. So these are two satellites basically separated by some gravity. So name is not Tom and Jerry exactly, but Grace and Grace FO. Gravity Recovery and Climate Experiment. So if there is some subsurface water change, based on the gravity we can infer amount of water underground. You understand what I am saying? What is the underground level of water? And time series is there. The data we have used in this study for 2001 to 2018. These are the planet scope. Nanosatellite means smaller satellite sent by one company. Different time series data we require so that we can say what is the change. Another, this is for Saudi Arabia, how much water is present from last 20 years and what will be the status in 2030. So here we are showing up to 2025. This will be the groundwater level. It may change, it may not change. It is just estimation. Forecasting is not always correct. It is estimation based on the previous data. So here the model was LSTM model. So what are the futuristic applications of AI? So AI is highly useful, like you see GPT-4, maybe they will launch 5, in NLP, in sustainability and healthcare, like automated X-ray. What are the sustainability we have? In education, AI is also highly useful. We can predict the student performance. In next semester, how this student is going to perform. Again, this is estimation. Suppose we are saying for one student that he is going to be very, very good in next semester. Maybe he says, okay, I am doing good. Automatically model says, and then he stops their education or their level of focus. Then maybe machine learning will fail. So this is just, good amount of estimation. AI in autonomous system, automated drones, automated cars, in creativity, human-machine interaction, AI in finance, ethics, and for social good. What are the suggestions for best practice? You need to know what exactly suits you, what is your problem, and what you want to apply, ML or DL. If ML is giving you good results with fair accuracy, then you can think or justify, do you need DL or not? Then domain is very, very important. What domain we are talking about? Because if somebody tell that I want automated systems related to AI, which will tell me the parking or the docking of ships. So for that we require domain person who are aware with that knowledge. Generalization, training data set is important. Your results are fair. And then good understanding of mathematics is highly required. These are the references. I'll happy to answer any question you have. I think I have completed in time, 12:59. But you should have questions. I'll be happy to answer. Thanks. Any question? Because if you don't ask question, I will start asking. My students know this.
So, can you talk about AI track and data science track in CS and how it's connected with
Yes, very good question. We have AI and data science track. In AI, machine learning is there, computer vision is there. In data science, it is introduction to data science, and then you have big data analytics. ML is everywhere. You go to any track, you cannot escape from ML. Why? In data science, we used good decisions on data engineering, feature engineering. When you are equipped with ML, especially you can use Python or R, but I suggest Python is more beneficial. Then you can do different type of works. So these like data science and AI are highly in demand. If you are equipped with the technology and you know the basic practical how it is working, you can develop some solution, then this is very, very good. So yes, we have tracks for data science and AI. Yes.
What do you think is more future to improve? Deep learning or NLP or machine learning or computer vision?
All of those. Why? Because when we say NLP, you see the success of GPT, BARD, and they are coming up with new solutions, voice-based command, maybe new things with image also. You give image, it will tell you, like if you are using GPT-4, but it will describe right now with image to text. Image to image, image to video is the upcoming future, which will, you just give some instruction, and based on that you are getting much more richer information. CV, computer vision is also very dynamic field. Why? Because we are evolving, data evolution is there. Different type of data we can do. And coupled with techniques like hidden Markov model. I am happy Majid is here, my GP student. So what he is doing, he is predicting the status of Majma, how Majma will look like in 2030. So we have data, earlier data, and we try to predict how this city will look like in 2030. You can apply it to Bureda, Riyadh, any part in the world. So means CV is also gaining momentum for sustainability and other requirements. So all these may be there. Maybe some new thing will come. We don't know. Yes.
What's the difference between machine learning and deep learning?
Very good question. What is the difference between machine learning and deep learning? So as I mentioned, deep learning, when we say, we are talking more about like CNN, RNN. So where automated feature extraction is there. You don't give feature on your own. Machine will extract. But when we say machine learning like SVM, KNN, you give features. You will tell machine that these are the features in your data. So data features not always in terms of image. You can convert what is image. Image is again numbers. Then it will have certain features. So let me tell you in very simple words, columns of the data are your features. Rows of the data are your records. More records are welcome, but huge number of features are difficult. Transformer, yes. Transformers are, when they invented, the person name I can tell you because I am very fond of this. In 2017, Vaswani have developed a paper. The paper title is Attention is All You Need. You just type on Google, attention is all you need. It's very, very phenomenal work. which start transformers. Nowadays, we can use transformers with different type of models we have, like BERT, distill BERT, and then it can give you so much good amount of information. It started 2017 by Vaswani. He was the person in Google Mind team. I think right now he's not working for Google. He's working on his own. But that was the starting point. Deep minds, yes. Any other question? Yes?
What are the sources you recommend to start learning machine learning?
Like if you are near to some level, then you can take AI track here. If you are in earlier level, then I suggest you can go for Coursera, and one of the best is like Andrews NG for machine learning and deep learning. I always recommend. But practical is highly required. This field is all about practical. And there are three things. One is theory, second numerical, how you solve. If you solve by your pen and paper something, 2 + 3 = 5, you can solve this problem anywhere in the world, any tool, any data. So what is the basic, what is the foundation is highly, highly important. Like you see K means KNN. And if I'll go give code 7-8 lines, not more than that, and you can apply any data in the world. Any other question? Okay then, thank you for listening, for your patience. Welcome.
Thank you, Dr. for your time. It's what